Okay, here's the normal probability distribution homework I promised I'd get to you regarding the TI calculator. And so let's get started on question 1 here. Now, when we read the statement here, let's make sure this iPad is pencil has sees and knows what's there, whatever goes on here with the world of iPad and pencil. Okay. The random variable x is normally distributed. So the second you see that, they're just saying this is a normal distribution. Of course, they're going to give you the mean, and in this case, the mean is 60. They're going to give you the standard deviation, and in this case, the standard deviation is 4. So the real question is going to be now to find the probability right in here that the variable is less than 53. That the random variable x is less than 53. So let's go back and remember a few things that we have to do. Draw your bow. Draw a picture of the question. Less than 53, right? So what you would do, draw your bow. And in the center goes your mean. So we're going to have to write down what that information was, right? The mean, standard deviation. And the question here really is what's the probability that x is less than 53? Now, I believe the mean was 60. But if you have to go back and you say, yes, the mean is 60, standard deviation 4. Okay. So your mean is 60. Standard deviation is 4. So right in the center of the bow here, this is where our 60 goes. Okay? There we go. Now, the number 53 is to the left of 60 because it's smaller, and smaller numbers live to the left of larger numbers. So 53 would be here. Okay? And remember, smaller numbers live to the left. There we go. So shade a portion of the bow that corresponds to the random variable x being less than 53. Okay, so maybe we need some applause there. This is what I mean when I say draw a picture of the question. Now, in the TI calculator, what we went through in class, and my bow doesn't look so good, as you guys know. Maybe I should have drawn a better picture of a bow, or at least come in here with a bow. Maybe do I have a bow here anywhere? Is there a bow I guess I don't. Note to self. Bow-shaped curve. Anyway. Remember how we work in the TI. Left to right. So remember, you start all the way on the left and you end all the way on the right, corresponding to numbers being less than 53. Now, it's like your feet getting wet. So you have a lower value and you have your upper value. So your upper value, ladies and gentlemen, here is going to be 53 when you use that TI, but the lower value is the default. And the further to the left you go, okay, the smaller the number, but remember our default's going to be negative 9949, 9,999, and that's negative. This is the default. So when we enter this in our calculator, we have to have an upper value and a lower value. Lower values are to the left, upper values are to the right. This all corresponds to the question. This represents numbers that are less than 53. So in the TI calculator, and you say, okay, what do I do in the TI calculator, right? Let's find out. So here we go. All right. So remember here, I think I'm going to scroll in. Well, let's do the first one scrolled out. We're going to go second, distribution. Normal CDF. That's number 2. Normal CDF. Okay. Enter. Negative. That's the lower value. 9999. That's our default lower value. Remember the upper value. If I go back to the iPad, upper value is 53. So I entered that in. We need the mean. The mean is 60. And we need the standard deviation to be 4 here. So as I go down here and I paste this, what we see here is our answer. Now, remember, we're going to approximate this to the 10,000ths position. So it's 0.040. Another position here. I know I have 0.59. So if I go to the iPad, the nearest 10,000ths position here. Tenths, hundred, thousandths, 10,000ths. Look at the digit to the right. Okay? 0.040059. Look at the digit to the right. If it's a 5, 6, 7, 8, or 9, we add 1. And sure enough, ladies and gentlemen, we're at 0.0401. This is the probability. Okay? This is the probability, which corresponds to really saying, if I move my decimal, if we want to talk about percents, this will be 0.401%. 0.401% of the bow is shaded here. And this is what they're looking for. But as a probability answer, it's 0.0401. Now, take a look here. If we go back to the iPad, let's find out what they asked. Find the indicated probability or percentage. Now, that's not very clear. Which one do they want? Do they want the probability value or do they want the percentage value? Well, I gave you both. On my test, I'm clear. I will say either probability or percentage. Now, when you go look at the answer for question 1, notice what they gave. This is the probability answer. And again, if they said percent, move the decimal 2 spaces to the right there, and you'll get 4.01%. Okay? So I just want to go over that issue because sometimes, like I say, it's not clear. And in this case, I would have said personally, hey, give me the probability or give me the percent. And that's how you answer question number 1. Okay. Question number 2. Again, notice what they say. Your random variable x is normally distributed. Oh, bell-shaped curve here. And this time the mean here is 15.2. And the standard deviation here is 0.9. Find the probability. When I read this is a probability notation that the probability is greater than, that's bigger than 16.1. So let's remember these important things. The mean is 15.2, standard deviation is 0.9. So for question number 2, I'm going to write that down. Mean is 15.2, standard deviation is 0.9. Remember the first step. Draw a picture of the question. Draw your bow. Now, my bows look funny. X is a normal distribution. In the center of that bow goes your mean, 15.2. So it's right in here. Now, remember what the question was. We're going to write it down. They're saying here in this question, what's the probability that x is, go back, what's the question? We want to be sure. Greater than 16.1. Okay. Greater than 16.1. So 16.1, ladies and gentlemen, is a larger number. It lives to the right of 15.2. Remember, larger numbers live to the right of smaller numbers on this real number line here, down here, this axis. So I'm going to label this 16.1. So when they say here again, numbers greater than this, larger numbers live to the right. So they're really referencing this interval in blue. So it's going to become, again, what percent of the bow is shaded? A shaded bow question. Okay, this is the picture of the question. That's what we want to do. Remember again, we work left to right. This is my lower value. And I have another default for the what? For the upper value. There's your default. Lower value, upper value. All right, in the TI calculator, we got a new lower value. So we have a lot of new information here. So we're going to go here now. Now what I'll do here, ladies and gentlemen, I'm going to scroll in so maybe some of you guys have preferred that. You say, I want to see if I can. Let me try to even, what is the deal? I'll move it there. Let's scroll in. Oh, what's that? I don't know what that is. Yeah, we want to move it down if we can. Can I do that? Oh, well, anyway. I guess I'm stuck right there. Let's keep it at that, okay? I apologize. I don't know why I can't really align it better than I am. Okay. Second distribution, normal CDF. Now remember, we have a new lower value, and that's 16.1. We have a new upper value, 9,999. So take a look at this, ladies and gentlemen, in the iPad. A new lower value, a new upper value. Don't forget to change your mean and your standard deviation. Okay? Don't forget that. You have a mean here of 15.2 and a standard deviation of 0.9. So in the TI, we get that option. Scroll to the next field, the mean, 15.2, and the standard deviation of 0.9. We're going to hit paste. And ladies and gentlemen, what you see here is the answer here. All right, now let's see if we can, whatever, we can't scroll in that field so easily. I guess that's the best we could do. Let's go out to the nearest 10,000s here, okay? So this answer is going to be approximately, let's write this down, 0.158655, right? We're going to approximate this to the nearest 10,000s. 10, 100, 1,000, 10,000. Look at the digit to the right. It's a 5. That means add 1 here. So your answer is going to be approximately 0.1587. This is a probability value. So if they ask you for probability, you give them probability. There you go. It's a picture of the question, ladies and gentlemen, for number 2. Now let's double check here that this is what is in fact is the answer. So if you go back all the way down here, sure enough, yes, right in here. Okay. Question number 3. The random variable x here, what they're saying, x is normally distributed. Now again, they changed the mean here. The mean here is 22. Standard deviation is 2.4 here. Now here's an example of the between situation. Okay, they're asking a probability between 19.7 and 25.3. Okay, so I'm going to do this again where I say, okay, the mean is 22, standard deviation 2.4. Mean is 22. Standard deviation is 2.4. Number 3. Draw a picture of the bell, right? The mean goes right in here. It's the center. Center of your normal distribution. There's your mean. Now remember the probability question. It's a between question. They want to know what's the probability your normal distribution x is between 19.7 and 25.3. 19.7 less than x less than 25.3. This is your random variable. Okay. So we now have to know, where do these numbers live? Okay. On our bell. We have to draw a picture of the question. So we need to know what does this question even look like? 19.7 is smaller than 22. So smaller numbers live to the left of larger numbers on the real number line. So here's where 19.7 will be. And 25.3 is larger than 22. So here's where my 25.3 would be. Shade numbers between here. Okay. There you go. Now, you need this picture because remember, when you use that TI calculator here, you need a lower value and an upper value. Okay, so we're working again left to right. All right, we know what to enter in the TI now. So let's go to the TI calculator and say, okay, what are we going to enter here? And I really would like to see, how can I do that? Is it moving it down? Maybe this helps. If I move it down here? No. Anyway. Here we go. Maybe we can see a little better here. Second distribution, normal CDF. Okay? The new lower value is 19.7, and the new upper value is 25.3. What's the mean? 22. What's the standard deviation? 2.4. Paste. And ladies and gentlemen, we'll approximate this answer again to the nearest 10,000th position. So this would be 0.74648. Sharing with you guys again. Tenths, hundredths, thousandths, 10 thousandths. We look at the digit to the right of the 10 thousandths. It's an 8. So it means add 1 to the 4. So this is 0.7465 approximated to the nearest 10 thousandths position. Okay? So let's take a look at that. This is what we want to do. Now, let's see if this is what we have in the answer. 0.7465 for number 3. That's odd. It's a little odd here. Now, I don't think we made a mistake. So let's fire the what? Let's fire the publishers. Not a bad idea. Not a bad idea. Anyway. Okay, ladies and gentlemen, you guys understand what to do here, right? So let me do this for you guys. The diameters of bolts produced by a certain machine are normally distributed. Diameter of bolts are normally distributed. What this means now here is this. X equals the diameter, of course, of bolts. So in that first sentence, this is what they're saying to us. Okay. All right. I apologize if you can't see that. Let's actually clear up this here. Okay, so we don't get distracted. So they're normally distributed. What's the mean? They're going to give you the mean. So they say the mean of 0.3, standard deviation of 0.01. So let me see if I can do this here. I'm going to say, all right, let's get this. Let's copy that. This is number 4. The mean of 0.3, 0.01. All right. Number 4. The mean is 0.3 inches. Standard deviation is 0.01 inch. Now let's see. X, remember, is the diameter of bolts. So I'm going to draw a picture and draw my bow. It's not the best picture. In the center of the bow is 0.3. Okay? We need a picture of the question, so we're going to have to go back and take a look at this and say, what are they asking us, right? Okay. They're going to ask us this question. It's a percentage question now. What percent of the bolts will have a diameter greater than 0.32? So this means X. Remember how X is the diameter again? X greater than 0.32. It is literally saying greater than this number here. This is the greater than symbol. And then you guys can see the number 0.32. So X is greater than 0.32. All right. Probability X is greater than 0.32. All right. 0.32 is larger than 0.3. Larger numbers live to the right. If you said, I have a little trouble with this, add a little 0 and think about it this way. 30 versus 32, right? 32 would be larger. It's to the right. And then greater than 32. So, okay, greater than 32. Larger numbers live to the right here. All right. So, ladies and gentlemen, this is how we go about this. As you guys know, again, we work left to right. So here's my lower. And then I have to have a default upper. 9,999. This is my default upper value. Okay? So we're all set. Just remember, there's a different mean, a different standard deviation. Okay, let's go to the TI. Okay, TI. Here we go. Second, distribution. Normal CDF. Lower value is 0.32. The upper default value, 9999. The mean, 0.3. Standard deviation, 0.01. We're going to paste this. And let's see what we get here. This is approximately, ladies and gentlemen, 0.02275. So if we go to the 10,000ths position, tenths, hundred, thousandths, 10,000ths, the digit to the right is a 5, add 1 to the 7. Approximately 0.0228. So, ladies and gentlemen, this here is the probability, okay? But remember, they asked for a percent, so move the decimal 2 spaces to the right, and that's going to be 2.28% now. Okay, 2 spaces to the right, we move that decimal because they asked us for a percent. So let's double check. Number 4. Percent. Number 4. 2.28%. We're looking at the answer here. And ladies and gentlemen, there it is. Alrighty, number 5. Let's get rid of this. What are they saying, number 5? Okay, they're going to say this. The incomes of trainees at a local mill are normally distributed. So X is an income. So X equals the income values. That's what they're saying. They give us a mean of 1100, standard deviation of 150. Okay. All right. Now they're saying, what percent, here's our question. It's a percent question, of trainees earn, let's see what the language is, less than 900. So, P X less than 900. This is incomes that are less than $900. And of course, that's in a month period. So, we're going to have to remember some of these things. 1100, 150. So now go back. Question number 5. The mean is 1100. Standard deviation is 150. Probability that your income is less than 900. I will double check that. Draw a picture of the bow. But let's verify. That's not a good bow. Let's verify let's verify the question. Less than 900, that's what it is. Okay. So now, ladies and gentlemen, again, let's move this out of the way. Okay. Let's get that out of the way. How's that? Nobody needs a logo. Who does that? Where's 900 in relation to 1100, right? Smaller numbers are to the left. To the left, less than 900, right here. There we go. So here it is. Lower values, upper values. Negative 9999. That's the default lower value. And we have an upper value of 900 because we work left to right. So there you go, ladies and gentlemen. There it is. Let's take a look at that. Let's try to enter this in the TI. All right. Let's clear this. Second, distribution. Normal CDF. The lower value is negative 9999. Our new upper value is 900. Now the mean, remember, is 1100 with a standard deviation of 150. We're going to paste this, and this is going to be our answer here. Okay? So let me again write this down. Let's write this down to the nearest 10 thousandths. 0.091211. And let's see in the iPad here. Tenths, 100, 1,000, 10 thousandths. The digit to the right is a 1. Remember that leave this digit alone. 0.912. So here's what we get. This is a probability value. Now, as a percent, if they wanted the percent, and I believe they did, you move 2 spaces to the right, that decimal. You now have the percent answer. And ladies and gentlemen, let's double check to see if we should fire the publishers. 9.12%. All right. And what do we get, if I remember? Fire the publishers. Anyway, actually, you know, what's really going on here, in case you guys didn't know, you know, I joke. But originally, when they did some of these computation, they used the Z table. And this is, you know, where they approximated and when they approximated. And that's a little bit different than what's it's being used in your calculator. So I'm glad we're going through this so that you guys don't lose your mind and say, oh my God, what am I doing, and lose some sleep. So you're good to go when you get this answer. All right. Let's read number 6. Number 6 says the volumes of soda, okay, in the soda bottle normally distributed. So X is the volume. This is what they're saying there. This is your random variable X, and they're saying we have a mean of 32.3, standard deviation of 1.2. Okay? What's the probability that the volume of soda is less than 32 ounces? So X, which represents the volume, less than 32. So you're really reading this statement as it's written down here. Okay? And again, this is a probability question. It is not a percent question. So it's the probability that x is less than 32. Number 6. Now, remember what the mean was. Okay, they told us that the mean will be 32.3 and the standard deviation is 1.2. Let's draw a picture of the bow. The mean goes in the center, right in here. So a picture of the question, they're saying, what's the probability that the volume is under, less than 32? So 32 in relation to 32.3 is to the left because smaller numbers are to the left. And if you said, oh, can I put 32.0 so I can see this, if you like? And again, like I said, smaller numbers are to the left. So they're to the left here. We're going to shade this here. It's a left tail question. All right, again, here, all the way to the left. This is a lower value. It's a default of negative 9999. This is our default lower. And then over here is our upper value. So this is what we need to use in the TI calculator for number 6. And remember, this here really is the question they're asking. So there you go. All right, so let's try this out in the TI. And I'm going to scroll out. I'm going to scroll out a little. I apologize. It's kind of a weird thing. You know, when I use my laptop, I'm able to really scroll in there. It's weird. All right, let's clear this out. Second, distribution. Normal CDF, number 2. The default lower is already there. Our new upper is 32. And then the new mean, 32.3. The new standard deviation now is negative 9999. Hit paste. And we did something wrong. There's an error. Okay. Second, distribution. Normal CDF. Let's try this out. Negative 9999. I'm going to make sure I do that. That's a negative sign. Okay. My upper here. I see what's going on. We have the wrong standard deviation. It's supposed to be 1.2. Okay. There we go. It's going to be fine now. Okay. I know. Fire the instructor. Keep the publisher. Hit paste. Okay. This is approximately, ladies and gentlemen. See what we have here. To the nearest 10 thousandths, let's write 0.401293. Let's start to take a look at this. Tenths, 100, 1,000, 10 thousandths. The digit to the right is a 9 here. Add 1. So this is approximately 0.4013. And again, here is our answer as a probability. And I think they wanted to know probability. Now remember, in the old days, they used a table. So here's 0.4013. And let's double check. Number 6. And it looks like this time with the table, all is well. And yes, they asked for probability. So there's your answer for number 6. Alrighty. We're going to look at number 7. Let's get rid of all of this here so we don't get distracted. Number 7, it says a bank's loan officer rates applications for credit. Okay. They rate. Ratings are normally distributed. So what does that mean? X equals the rating value. This is what they're saying there. Okay? They have a mean, though, of 200 and a standard deviation of 50. Okay. So, mean of 200, standard deviation of 50. What do they say? If an applicant is randomly selected here. All right. It's a probability that the rating now, here we go, X, that's a rating, is between 200 and 275. So X is between that value. So what they're saying, 200 less than or equal to X, less than or equal to 275. This is their question. So number 7, 200 to 275. So $200 to 275. Remember, we need the mean now. See what the mean was. And the standard deviation. The mean is 200. Standard deviation is 50. Okay. Oh. Okay, so let's draw a picture of the question. This is where that mean belongs, 200 right here. Now, the question is probability that it's between 200 and 275. So here's 200. And here's 275. There you go. Picture of the question. So remember, you have a lower value on the left, and then you have an upper value on the right. So you have a lower, you have an upper. Okay? So we're going to enter this in the TI calculator now. And remember, we have new information. So in the calculator, let's go there. Second, distribution, normal CDF. Lower value is 200. Upper value is 275. The mean down here is 200. Standard deviation, again, is 50. Paste this. And this is a probability question again, right? So we're going to go out to the nearest 10,000. So it's 0.433. Now look at that digit. It's a 1, but the digit to the right's a 9. So ladies and gentlemen, it's going to be 0.4332. So double check here. Now that is a probability value, okay? 0.4332. It is 43.32%, but in the question they asked for probability. So in number 7, let's double check. And sure enough, it looks like we're fine. Keep the publisher. All right, let's try number 8 here. Oh, it looks like it's very similar to number 7. I said, wait a minute, a bank's loan officer rates, ratings are normally distributed? Oh, that's the same as number 7. So this is X. X equals the ratings. Okay. But what are they asking now? Look at this. Has a mean of 200, standard deviation of 50, just like before in number 7. So if an applicant is randomly selected, find the probability the rating now is between. Okay. X is between these two numbers. This is what they're saying now. Probability 170 less than or equal to X less than or equal to 220. So it's another probability question, but it's a different probability. All right. That's nice to know. So number 8 has similar information. I'll put it here. But let's actually take a look at how this would be. Okay, we're going to draw a picture of this bell now. I'm going to even copy the bell. Okay. What's going to be different is really all of this. The mean still is 200. Standard deviation is the same. But the random variable X, this normal distribution, these ratings are between 170 and 220. So I have to think about where does both 170 and 220 live in relation to 200. Now, the lower value here of 170 is smaller than 200, so that's where we will place it. It's really not to scale, these pictures, just to let you guys know. And then 220 is larger than 200, so we're going to put that value here on the real number line there. So now I do have my lower and upper values. They want to know what percent of the bow here is shaded. So you now have, again, the lower. You have the upper. What percent of the bow is shaded? Okay, let's try this out now. TI between 170 and 220. So it has the same mean as number 7. 200's the mean. Standard deviations 50. So it has the same mean. Okay? So in the TI, I just have to remember the new lower. Second, distribution. Normal CDF. The new lower is 170 and the new upper 220. The mean is the same, standard deviation is the same. Paste that in, and ladies and gentlemen, we're going to approximate this probability value to the 10,000th position. So if you read that, that's 0.3811. The digit to the right of, we got 0.3811 is a 6. That means write the last digit as a 2, ladies and gentlemen. So your answer is going to be, as a probability, 0.3812. So my advice always is draw a picture of the question here, because that's going to help you. Let's see if we get the publishers to agree. 0.3812. And notice this. You go, what happened with the publishers here? Well, again, approximation. There's a problem here. Let me cross that out. I don't know where we're at. Wrong page. 0.3812. So I am glad, ladies and gentlemen, we are going through it this way. And there's your solution. But again, it's a matter of approximation in all of these calculations. In the past, we used the z-table. That's really what's happening. So anyway, number 9. So it's good to know to go through this. I'm glad. All right, let's look at number 9. Let's read what they're saying. In number 9, they're saying that the lengths of human pregnancies is normally distributed. Now, personally, there's nothing wrong with saying length. I would say day. The days of human pregnancies are normally distributed. They call it the length. So I'll just put X as length or X as days. This is what they mean by that first sentence. Okay. No big deal. But if you notice, they have a mean of 268 days and they have a standard deviation of 15 days. Okay, now they're going to say, what is the probability that a pregnancy lasts? Look at this phrase here. At least 300 days. So since X is the number of days women are pregnant, at least 300. Remember, at least means 300 or more. So that is greater than or equal. This is the at least phrase. At least what number? At least 300. Okay, so here's that 300. This is the number of days being pregnant. All right, let's write this down. This is question number 9. I'm going to copy this here. Remember, the mean is 268. Standard deviation is 15. The mean, 268. Standard deviation is 15. Let me double check. Yes. Okay. And remember the question. What's the probability a pregnancy lasts for at least 300 days? Okay. Here we go. Draw a picture of the question. I would never attempt to do this without a picture of the question. In the center is your mean of 268, the center of the bow. Now, this is the number of days being pregnant. So the probability that you're less than or equal to at least, wait a minute, I think we made a mistake. At least is 300 or more. That's greater than or equal. Let's go back. Let's double check. I did put greater than or equal. No, I'm looking at the wrong thing. Okay, right here, at least, ladies and gentlemen, is 300 or more. That means it's more. Greater than, this is the more part. Greater than or equal. Made a mistake. It's not a mistake if I find it. I found it. At least. Greater than or equal. Great. At least is greater than or equal. Found it. I know. 300 is to the right of what? 268. Is that right? So at least 300 or more, the values of X, those are the values that go to the right forever. It's a right tail. Shade a portion of the bow that corresponds to your right tail. Now, ladies and gentlemen, right, working left to right, we got a lower value of 300. But this goes on forever. So remember, we use the default 9999. So we have all the information we need to use in our TI calculator. Okay, here we go, ladies and gentlemen. Let's try this out, okay? And the TI. So go to the TI now. I want to clear this out. Second, distribution, normal CDF. My new lower value is 300. My new upper value is 9,999. The mean here again is 268, and the standard deviation is 15. So we have to change these values. And sure enough, you hit paste, and here we go. So if we approximate this answer to the 10,000ths, again, we see 0.0164. The digit to the right is another 4. So ladies and gentlemen, here's your probability value. It is 0.0164. And yes, they didn't ask this, but this is about 1.64%. Just to remind you guys, let's check to see if number 9 is correct here. 0.0164. All right. This is number 10. This is number 10 here. Or number 9. Sorry, I'm getting a call. Getting a phone call in the middle of a video. Really? It happens. All right. Number 10. Assume here. What are they saying in this one? Assume the weights of quarters. The weights of quarters are normally distributed. Oh. Okay. The weights of quarters. So X is the weight of quarters. All right. Now, it's normally distributed. It has a mean of 5.67 grams and a standard deviation of 0.07 grams. Okay? Now, here's what they say. A vending machine will only accept coins weighing, again, this is another what? Between situation. So, between what? They're asking the percent here. What percent of, oh, hold on. Oh, let's read this. We're not reading. We're not reading. Here we go. This is an interesting question, number 10, ladies and gentlemen. So let's read this. A vending machine will do what? This is when you accept the coins. Weighing between these two numbers, 5.48 and 5.82. This is number 10. And then they're going to say, what percent of legal quarters will be rejected? I'm going to write it all down here, ladies and gentlemen. I apologize. I'm going to do it right in here. So I'm going to do this. Okay? Draw your bow. The mean is 5.67. So we're going to write that down here. The mean will be 5.67. Standard deviation will be 0.07. Okay? Now, notice what they're saying. They're saying a machine will accept coins weighing between 5.48, you know, that's actually to the left of 5.67, and 5.82. Well, that's larger than the mean. So what I want to remark here, this is the accept region. Okay? And then notice they say, what percentage of legal quarters will be rejected? So the reject region here, I'm gonna paint in gray. It's the tails. It's both tails. This is where you'll be rejected. It's outside there. All right? So this is the reject region in gray. And they're going to say, what percent of quarters will be rejected? So we need a game plan, ladies and gentlemen. We need a game plan. Let's really think about this, okay? To be accepted, it's between these two values. To be rejected, it's the complement of these values. Oh, I see. So I'm going to say use the what? Complement rule. I like this question. Wow. Complement rule. Love it. So here's my game plan here, ladies and gentlemen. here's what I'm going to do here. This is number 10 here, okay? So for number 10, and maybe I should have just copied that bell, yeah. I'm going to copy this. Okay, here's my game plan. See if you guys can appreciate this. Number 10. I like this thing. Interesting. You know what my game plan's going to be? I'm going to use the complement rule. Probability of being rejected is 1 minus the probability of being accepted. This is what I'm saying. This is the complement rule. Outstanding. Great. All right. Now, the probability of being accepted means the coin has to weigh between these two values here. Okay? This is the accepted region here. So now in your TI, you say, is this my lower and this is my upper value? It is. And you're now able to actually answer this question because they want to know not the probability of being accepted, the probability of being rejected. Use the complement rule. That's why we studied it. All right. So notice this too. I can enter this all in my TI rather nicely. Here's what I mean. I can put 1 minus second distribution, normal CDF. My lower value is 5.48. My upper value is 5.82. The mean for these coins, don't forget, is 5.67 grams. And then the standard deviation is 0.07. So if we paste this in, ladies and gentlemen, that's our final answer, but it's the complement. You guys remember? And weird, why doesn't it let me just scroll up to the top? Anyway. You guys can see that. Okay, let's go to the near. Did they ask probability? Let's give probability. Okay, 0.019. 0.019. It should be a 3, but the digit to the right's an 8, so that's 0.0194, ladies and gentlemen. And this is the probability. There you go. What do you guys think of that? That's the chance. That's a good question. Let's see if the publisher got it right. Okay? Oh, they asked for a percent. So let me go back. Let's do the percent. Move it 2 spaces to the right. This is 1.94%, ladies and gentlemen. Okay, and then let's see if the publishers got this right. And as you guys can see, they didn't. And it's just an approximation because they used the tables for this in the old days. And the TI is actually more accurate than the table. So again, some of these different answers are because your TI goes to a much more accurate place value. Your tables didn't go as accurate. And as you can see, approximations have an effect, 1.94%. So glad we're going through this. Now, the rest of the questions you guys see here are going to be the backwards situation. Okay? So let me get rid of this distraction and share with you guys here, working backwards. And then when you work backwards, remember the function in your TI. That's inverse norm. Right? So for questions here, they say, find the lifetimes of light bulbs of a particular type of normal distribution with a mean of, all right, let's get this, 392 hours, a standard deviation of 9 hours. So the lifetimes of light bulbs. So here's what they're saying. Let's read it. The lifetime of light bulbs are normally distributed. So X equals the lifetime. You know, a lifetime is just simply the length of time that a light bulb works. It's called a lifetime. You know, we think of people having lifetimes. You know, the age you die, that's your lifetime. So evidently, even objects can have a lifetime in theory, and that's just in this case how long a light bulb actually works. Call that the lifetime, and it's normal. It's a normal distribution, is what they're saying. Has a mean of 392 hours. Has a standard deviation of 9 hours. So let me write that down. I'm going to put down my mean here. Going to be 392 standard deviation of 9 hours. Okay. So notice this question here now. They're going to say, this is a different question now. They're going to say, find the first quartile. You know, first quartile. What in the world does that mean here? First quartile. Find the first quartile. Now, we did discuss this in class. I'm going to kind of cover that up. If you guys remember, the mean here is 392. That goes in the center here. And what I said in class here, if you guys remember, the first quartile value has that's a threshold value. That's the 25th percentile. Over here, you have the third quartile value. And that's the 75th percentile. Now, notice here, the second quartile value is actually that mean here because that's P50. So this is going to be Q2 here. Right? I want to write it down here because they're saying find the first quartile value. Now, for those of you guys that might have missed it, that means 25% of the bell is here. This is another 25%, 25%, 25%. Okay? So we have important information to use. They want us to find the first quartile value. Right here. That's the question, Q1. Now, let me copy this here. We don't know what that value is. I'm going to call that value X. Okay? So I'm going to copy this question because an X is the lifetime. See if I could copy all of this here and bring it to my Scratch work. I think I want to copy all of this. And this is number 11. Working backwards. Now, remember what I said the other day? Okay. You're going to use inverse norm. This is working backwards. But it depends on what TI calculator you have. Now, I'm going to represent this here as a left tail situation, because remember, this is where 25% of the bell is. So I'm going to present this here as a left tail, 25%. This is going to help me. So 25% of the bell is shaded. We want to know for what X value that happens. That happens to be the first quartile. So let's go to the TI now. And we'll clear this out. We're going to use second distribution again. Now it's inverse norm number 3 here. Now we're going to have to put an area. So just scroll through again and take a look. Oh, it needs an area. Okay, I'll put 0.25 then, since I need an area. The mean of the lifespan was 392. The standard deviation was 9. Now look at the tail. They're saying, is this a left tail? Is it a center? Which is really contradiction because a center is not even a tail, but whatever. they're talking about area, or is it a right tail? So if I go here again, when I enter the 25%, okay, I enter the decimal representation of a 25%, notice this is a left tail. So I'm going to need in my TI to indicate, hey, left tail now. This must be a left tail because the area is 0.25, 25%. Now hit enter. And so, ladies and gentlemen, this is the value they're looking for. 385, which is like, let's approximate to the whole number, which is 386 here. Okay? It's kind of odd. I really wish I can do that. Why can't I do that? Yeah, I don't know. Guess that's the best we can do. 386 to the whole number. All right, that's my X value. So nevertheless, X, which is that Q1, which is P25, which was 386 as a whole number. So this is what they're looking for here. They ask for that threshold first quartile value. 386. So let's see if the publishers got it right. And they didn't approximate to the nearest whole number. That's fine. I did. So this is 386. Okay, ladies and gentlemen, get rid of this portion and we're done. 386. Okay, that's what they want to know. It's working backwards. Okay, now take a look at question number 12 here. I'm going to get rid of this here. Question 12 is now changing some things here. What is 12 saying now? At one college, GPAs, grade point averages, are normally distributed. So X is your, or is a GPA. That's all they're saying here, ladies and gentlemen. X is a GPA. But they have a mean now, a mean grade point average. This is what they're saying right in here. And I'm going to erase this. You have a mean GPA of 2.6. So my 2.6 goes up here. You have a standard deviation of 0.4. Okay. So grade point averages are normally distributed. Okay. Find, now they're saying find what? The third quartile value. Maybe we should color it a different color. Q3. Now remember what we said Q3 really is. It's right here. Q3 is the 75th percentile. Okay? So in the bow, yes, this is 2.6. This is where the mean goes. They want us to find this X value, Q3, the third quartile value. Now, this is where things get a bit interesting. You're going to have a choice here. So do you want to see this as a right tail? I'm going to say this, look at this 25%. I'm going to look at this question as a right tail. So I'm going to paint this red. And I'm actually going to get rid of this information here. And I'm going to share with you guys, this is a right tail now. Okay. And that's 25%, but now it's in the right tail. We're finding that threshold value. You see, the TI calculator, this version, the CE version, is kind of nice because you go to the inverse norm, second distribution inverse norm again. I want to keep that 25%. Same, oh, not the same mean. Mean is 2.6. This is a GPA question. Good. Change the mean. Standard deviation is 0.4. It's a GPA question. All right. Now, here's what I'm getting at. This is a right tail where 25% of the area is in the right tail. So in your TI, you cannot use left tail for the CE version. You're going to have to use the right tail. So you say, okay, here's my right tail. Scroll that down and hit paste. This is going to be my answer. The GPA value, this is an X value. Let's go out to the nearest hundredths for GPA. So what did we just find here for the X value, right? We found that X value for the GPA is 2.87 to the hundredths. 2.87. Here is my answer here. All right. Now, let's see if we can fire the publisher. No, we get to keep the publisher. Because this answer to the nearest tenths or hundredths is 2.87. So, ladies and gentlemen, it looks like they are okay. Let me change that to blue. And that's actually question 12, so fine. So, ladies and gentlemen, here's going to be the thing about this, okay? What's going to happen is some of you guys are going to have a calculator that doesn't even give you the option of what? A right tail. Like, for example here, TI 80. If I change my calculator to not the CE version, there should be a way to change this. What happened here? Yeah, oh, I guess it's down here. Sorry. If I change it to the TI 84 Plus now, and you say, Mr. Judge, I'm going to clear this out. Uh-oh. My TI 84 Plus is frozen. All right. TI 84 Plus C. Clear this out. Let's get this. Let's give an error here first, I guess. Let me get rid of this stuff. Whatever. Clear. Clear. If I go second distribution, inverse norm, which is number 3, the inverse normal distribution, you're going to see I have area, I have a mean, and I have a standard deviation. For the problem we have now is we got to enter an area. Now, for the TI-84, the default is area to the left. Area to the left is the default. So some of you guys may have that calculator. And what I want to remark here is that the default area to the left is going to require you to take 25, 25, and 25 to describe the portion of the bow here that's to the left of this value here as 75%. So you're using the default. So it's area to the left of the value of the Q3 value. Area to the left of the Q3 value. Area to the left of that number, and that's 75% now. So if you hit 75% as a decimal, 0.75, the mean is 2.6 because it's a GPA. Standard deviation is 0.4. You're going to paste that in, and ladies and gentlemen, you get the same exact answer. Well, let me go back. Is that the exact answer? Approximated to the nearest hundredths, it is. It's 2.87. So the default works as 2.87 again, and that's going to be for some of you guys who don't have the option here of the right tail. But the point is, you need to understand about quartiles, quarters, 25%, 25%, 25%. And again, here, this is also 25%. So you need to use either the area to the left of that number or area to the right. And some of you guys have TI calculators that use that default. Giving you guys a lot of detail. All right. Okay. All right. Let's get rid of some of this here. GPA. We're going to go to the next question. Look at the next question, number 13. The amount of Jen's monthly phone bill is normally distributed. So her bill is normally distributed. So X equals the bill. How much it is, how expensive it is. Evidently, she has a mean of 76, standard deviation of $12. So we're going to write that down. 76, standard deviation of 12. Okay? Now, find the first quartile value. You go, oh, what's that? That's again over here, the first quartile value. So what I'm going to do now here again for this first quartile, I'm going to use a left tail. Notice that's the same as the default. Okay, so I'm going to use a left tail, so that means 25%. That's also the what? Default. Okay? I need to find that number. That's the X value, if you want to think of it that way. That's the cost. That's the bill that we're saying. That's this value of X. So we're looking for that number now. All right. TI. I'm going to go back to I'm going to change this to the CE version. Second, distribution. Inverse norm, number 3. And, 25% is there. Good. My new mean is $76. The new standard deviation is $12. And this is now, again, a left tail. And that's the same as the default. So I'm going to use that. Ladies and gentlemen, 67.9. And since this is money, let's go out to the nearest hundredths. Because this is money now, right? You can have a bill that's not $67 even. It's 67 here to the nearest penny. 906 means it's 91 if we approximate to the hundredths. Okay? You guys okay with that? 67.91. So this is what they're looking for. I'll put it right up here. $67.91. And that's the first quartile. Let me get rid of that. That's what they're looking for right here. 67.91. There we go. And that's number 13. So let's see if the publisher, 67.9. Yeah, again, I'm glad we're going through this here because these are answers that were pre-TI stuff. Let's do it in red like we've been doing. $67.91. That's pre-TI. Question number 14. Okay, I'm going to get rid of all this here. Well, maybe I shouldn't have. Let's look at the next question. Question 14. Okay, we'll actually put it below here. The annual, let's see if we can say that. Precipitation, rain, for one city is normally distributed. Okay, the annual precipitation, the annual rain is normally distributed. Okay. So that's your variable X. Right? So you're going to say X is the annual rain precipitation. Number 14 here. And they're going to say the mean here is 38 point, that's a lot of rain, right? 38.8 inches. This is what they're saying. That's our mean. Standard deviation is 3.5 inches. So we're going to put that here. Standard deviation is 3.5 inches. Okay. And then look at the question now. Find the what? The second decile value? Oh, they're going to make me review and remember that the second decile value that's D2, which is P20. It's the 20th percentile for D2. Okay. So for number 14 now, let's draw a picture of the question here. Okay. Here's your bell. 38.8, right in the middle. Now D2, 20th percentile, anything smaller than 50 percentile, right? Remember, this is actually here. This is P50 or D5, okay? So that means D2, 20th percentile, has to be to the left. 20%. %20 of the bell there is shaded here, and that's a left tail here. So there's our D2. They want to know what that value is. Okay? Take a look. Now, in your TI, let's try the TI here. We're going to clear this out. Second distribution, inverse norm. 20%, 0.20. Area to the left, but we need a new mean. Precipitation, rain, is 38.8. Standard deviation is 3.5. Area to the left, that's a left tail. And, I guess we'll go out to the nearest what? Hundredths. Okay. 35.854 is going to be to the nearest hundredths. The 5 is in the hundredths position. Digits are right to 4. 35.85. So, ladies and gentlemen, 35.85 here. This is in inches. That's what they're looking for. So this is actually question 14. So I say 35.85. As you guys can see, yet again, this isn't Fire the Publisher. It's actually just, ladies and gentlemen, in all honesty, it's an approximation issue. Whether you use the z-tables that were done in the past to do this, or use your more accurate calculator to do this, the TI, that's really where the difference is. Anyway. Let's look at number 15. We're almost done. Oh, look at this. Assume that women have heights. The height of women is normally distributed. So, you say, what does that mean? That the height of women is normally distributed. So, X is simply the height of women. And then they give you the mean in inches. The mean in inches is 63.6 inches. Not percent. That's inch. Standard deviation is 2.5 inches. Interesting. For men, by the way, the standard deviation is 2.9 inches. So that means the height of women is more consistent. Women have more consistent height. And it looks like 5.36 inches. That's 5 foot, almost 5'4". Average height of women is almost 5'4". Now, what are they saying? Find the what? Third quartile value. All right, third quartile. We already went through that, in all honesty. third quartile, remember, 63.6, that's really the 50th percentile value right here. Okay, remember, 50% of the bow. It's also Q2 by definition. So the third quartile, again, is to the right here. Q3. Now, you have a choice here. If you use the default, I'm going to do that for this question here. This is area to the left. Remember, area to the left, this portion is 25. This portion is 50 for a total of 75. So we can use left as the default because you have that 50 and 25. Okay. So what I'll do here then is try it that way. Okay. So clear out. Second distribution, inverse norm, ladies and gentlemen. 75% of the bow. And then the mean here, the height of women, the mean height is 63.6 inches. And a very consistent 2.5 inches. Okay. Now, again, I'm keeping it. It's not even a tail, but it's just area really to the left of the value. It's the left of Q3. That's what they're talking about. Area to the left here. So I'll keep that, hit enter in the TI, paste this, and let's go out to the nearest, okay, we'll do hundredths again, I guess. So what do we get for Q3, right? What do we get here to the nearest hundredths? 65 point, not 28, but 29 inches here, okay? 65.29 inches. Now, what that means here is, to the tenths, it is 65.3 inches. So, looks like the publishers were okay on this one for number 15. And good. That's amazing. All right. The last one. Number 16. Okay, the last one. There we go. A bank's, let's go back to the bank here. Let's get rid of this stuff so it doesn't distract us. Okay. And notice what they're saying now here. Okay. A bank's loan officer, there's the bank again, rates applicants for credit. The ratings are, X is the ratings normally distributed. So X equals the ratings. The mean is 200. The standard deviation is 50. So in the center here is 200. That's your mean. Okay? All right. Now let's look at the question. They're going to say, find here. Find the sixth decile. This is D6, ladies and gentlemen. Okay? And you have to remember the definition. That is P60. That's the 60th percentile by definition. So like we said earlier, right in the middle is D5, which is P50. Okay? D6 is to the right, ladies and gentlemen. This is where that sixth decile value is, because that's the 60th percentile. What that means is, area to the left here is supposed to be, this whole thing is supposed to be 60% right in here. Okay, I'm going to use the default again in honor of those that have those calculators. So this whole thing is supposed to be 60%. Okay? 60% of this value. That's what we're looking for. So in your TI now, let's keep this information here. Clear that out. Second distribution, inverse norm. Now that's 60%. We have a new mean here. The mean rating is 200. The mean standard deviation is 50. This is all area to the left. You're going to hit paste. And sure enough, we're going to go to the nearest whole number because, you know, it seems like ratings are to the nearest whole number. Whole number means the ones position. So the digit to the right is a 6. Add 1 to the 2. The answer, ladies and gentlemen, is 212. That's this. That's D6 or P60. Okay. 212 if we go out to the nearest whole number. So let's see if the publisher was correct. Well, the publisher, you know, I'm going to do this. Remember, it isn't really that the publisher was wrong. It's just they used the tables back in the old days, the Z tables, and those are less accurate than your TI calculator. And so since I'm allowing the TI calculator, ladies and gentlemen, you know, I just have to go through and share with you guys what's really going on here. All right. And that's the end of this demonstration. So I hope you guys enjoyed this. Study hard. You're going to just use your TI, and good luck, ladies and gentlemen, and take care.